This is part 2 of the JavaScript regular expressions module in the Legacy JavaScript Algorithms and Data Structures course on freeCodeCamp. This video will cover steps 12 through 22 of this module. We're going to start with the .match function for matching characters that occur one or more times in a string. So here it's asking to match in the instance of the string Mississippi in the object difficult spelling or the string difficult spelling. We're going to have to match and return arrays containing any instance with the letter S. So here that is accomplished using the plus character syntax to see if for repeating characters in a string. So that's exactly what we're going to do here in the change line. We're actually just going to put S plus because we want to return any instances of the letter S in this Mississippi string. After the single slash, we're going to add a global flag because we don't care how many times the letter S is returned because the S it's essentially the same string being returned again and again. So we're going to run that and we see that it works. So we'll move on to the next step. Here we're going to be matching characters that occur 0 or more times. And this is accomplished using the star or asterisk syntax. So in this step or challenge, we're given the string chewy quote, and it's not in the source code here. So we're going to instead create a regex chewy regex that uses the star character to match only uppercase A character. So here in the change line, we're going to write A star. With the uppercase A character immediately being followed by 0 or more lowercase a characters in chewy quote. So again, we're going to use the star or asterisk character to match uppercase A character immediately followed by 0 or more lowercase a. So we probably would put a lowercase a and then followed by an uppercase A with the star syntax in that change line. Let's see if that works. So in the example here, we want to match this string here. So it would be starting with an uppercase A followed by a lowercase a. So we just would change the positions of those strings where there's characters. And that works. Next, we're going to find and match characters with the lazy matching syntax. So here, the challenge asks to change this regular expression to return the tag h1 within the brackets using the lazy matching syntax. And essentially the lazy matching syntax involves an asterisk or star followed by a question mark in between the first and the last character of which the function will match. So here in this example, we're going to, because the string here starts with the bracket H and ends with one close bracket, we're going to actually input that right here as a replacement for the wildcard dot. So we'll type in here H asterisk question mark 1 because we want to return only the tag H1, but anything in between those endpoint characters, which is what is highlighted here, is essentially enclosed within the asterisk question mark syntax. So we're going to try that out, and it works. The next challenge is to find one or more criminals that escape from a jail. So here, the criminal is represented by the capital letter C. So we want to find any instances of the match, rather, we want the function to return or match any instances of the capital letter C in the regular expression. So here I give some examples with Z, with strings that contain the letter Z here, with the plus syntax. Including instances where the letter Z in this example appears one or more times in a row, such as here and here and here. So this is also known as a greedy regex because it's going to find one or more instances of criminals. So we're in this line here, we're going to simply change this period to a C plus, capital C plus. And it works. Again, we're not using any flags for this instance because we are specifically looking for criminals that are represented by a capital letter C, not any case letter C. So that's why we don't use any high case insensitive flag, nor do we use any global flag because that's taken care of by this plus notation. Next, we're going to match beginning string patterns. So previously, in a previous challenge, the caret character was used to return what was called a negated character set, so anything that wasn't the characters following the caret. And this notation can also be used outside of a character set for patterns at the beginning of strings. In the challenge here, we're going to use the caret character in the regex to find capital CAL only in the beginning of the string Ricky and Cal. So here we're going to change this to caret CAL. And that works. So this challenge is asking to match what are called ending string patterns. So this is essentially the opposite function as the caret. This is denoted with the $ character at the end of the regex instead of the beginning. So caret was the beginning, the dollar, whereas the $ character is at the end. So here we want to use the $ character to match the caboose string at the end of the caboose string object. So here from change, we're going to match that syntax by typing in caboose $. Just like in this example, we have story $, because story is at the end of the string. So in this test, this will return true because story is in fact at the end of the string and the ending string. So we're going to test and it works. Now there's a special character or syntax rather to match all letters and numbers, which is /W. So this is equivalent to literally all characters, which are denoted as such. It includes upper and lowercase characters, of course, and underscore. So this again, this /W is a shorthand for this type of character class. So here we're going to use the shorthand character class /W to count the number of alphanumeric characters in the strings. So here we'll just type in /W plus. And the reason why we're counting the number of characters is because we have the .length function here in JavaScript, which will return the number of characters rather than the characters themselves. And here we have to use the global flag, so we'll remember to do that because we don't care whether we don't care how many instances of repeating characters there are. So we'll add the G there. We'll probably also add the case insensitive flag because we do have a mixture of upper and lowercase characters in this quote sample string. Perhaps we would not include the plus sign in this challenge. And that works. There will be no plus sign there. Because we're only looking for the instances of the characters, the length of which, not instances of repeating characters. So that's why there's no plus sign there in the string. So basically, in this challenge, the caret can be combined with the /W shorthand character class by using a different shorthand character class /uppercase W. So essentially, using this syntax in the string will match any characters that are not alphanumeric. Uppercase letters, lowercase letters, digits, and the underscore. So anything that's not any of those types of characters, it'll return. So here the challenge is to use the shorthand character class to count the number of non-alphanumeric characters in the string. So here we're just going to type in // uppercase W, and then we'll still add those ing global and case insensitive flags. And it works. So in this particular example, the string, the only character that would be matched or returned would be this period, because everything else is alphanumeric. So here, the challenge asks to use a different shorthand character class, /D, which only will match or return digits, 0 through 9, the lowercase d. So here if we're asked to use this shorthand character class to count how many digits there are in the movie titles, we would just do the right in here, the /D with the global flag, because there could be multiple instances of the same digit, namely here the zeros in the string. Oops. And here, this challenge is asking for the returning of what are called non-digit characters, basically anything that's not a digit. So that's what we're going to do here to count in the string how many non-digits there are. /D with the I and G flags, because there are non-digit characters that are in different cases, such as the capital A, and then you have a lowercase p, a lowercase a, etc. In the final step of this video, we're going to incorporate many of the syntax utilized in the previous steps in a string that actually restricts possible usernames, given these 4 criteria here. Essentially, we're going to be creating a string that checks usernames in a database. And the first criterion is that the usernames can only be alphanumeric characters, meaning either A through Z or 0 through 9. So we're actually going to start by changing this line here to the bracket notation and the caret. The reason why we're going to start with a caret is because the second criterion just delineates that only numbers in the username occur at the end. So meaning the username must start with an alphabet character, A through Z. And there could be as little as 0 numbers in the username, meaning there could be one username with only 2 letters. So in that case, there will be a vertical bar notation or an OR operation to denote these 2 different cases. And in both cases, though, the username starts with the alphabet character. And in the third username, the username letters can be either uppercase or lowercase. So we'll use a case-insensitive flag at the end to allow for usernames to start with a capital or lowercase letter. And finally, criteria number 4, these usernames can be at least 2 characters long. And a 2-character username can only use alphabet letters as characters. So in that case, we would actually copy this same syntax here in the first case, paste it, and then add the plus syntax because the letters can be repeating essentially. And then we will end this case with a backward slash dollar, pardon me, D and then dollar syntax with an asterisk because there could be characters in between, or digits in between the first letter and the last digit. Hence why we have the asterisks here. In the second case, there will still be a second letter here, but the difference is that we'll have a backwards D. This would be a plus. Actually, there would just be digits in between the first letter and the last digit. So this would be a backwards D plus syntax, followed by a second backwards D dollar sign syntax to denote any digit that the username ends with, essentially. Does that sound? It works. So this concludes steps 12 through 22 of the regex or regular expressions function module.